Today we're going to talk about multiplication. Multiplication is the repeated addition of adding a number to itself. I'll show you how to visualize that in just a second. Unlike addition, most things can be multiplied together. You do not need like terms to multiply. When you do multiply, make sure you remember your exponent rules when you multiply things with exponents, not just variables, anything with exponents. So for instance, if we have x squared times x to the fourth, that's x 2 plus 4, same base, multiply, we add our exponents, so that's x to the sixth. Visualizing multiplication. When we visualize multiplication, this is saying 3 times 4 is saying 3 groups of 4 rectangles. So we have four rectangles and 3 groups of that. 1, 2, 3. 3 groups of 4 rectangles. If you count them, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3 groups of 4 rectangles is 12 rectangles. So 3 times 4 is equal to 12. Three times negative 4 is 3 groups of negative 4 rectangles. So it's the same thing we just did, only we have negative rectangles instead of positive rectangles. So 3 times negative 4 is equal to negative 12. 3 groups, 1, 2, 3 groups of negative 4 rectangles. All of our rectangles are negative, so our final answer is negative. Negative 3 times 4. Remember, when we had this negative out front, that was saying it was the opposite. So negative 3 times 4 is the opposite of 3 groups of 4 rectangles. We just found that 3 times 4 was equal to 12, so the opposite of 12 is negative 12. So negative 3 times 4 is negative 12. That makes sense because we know that our multiplication property is commutative. So 3 times negative 4 is negative 12. We just found that from the previous sides, and negative 3 times 4 is negative 12. Using this opposite fact again, we have negative 3 times negative 4. This first one is saying the opposite. The opposite of 3 groups of negative 4. So 3 groups of negative 4 was negative 12. This one was 3 times negative 4 is negative 12. That's what we found 2 slides ago. When we want negative 3 times negative 4, that's the opposite. This part tells us it's the opposite of 3 times 4, negative 4. The opposite of 3 times negative 4 is the opposite of negative 12, so that's positive 12. So in general, a positive number times a positive number is equal to a positive number. A positive number times a negative number is equal to a negative number. A negative number times a positive number is equal to a negative number, and a negative number times a negative number is equal to a positive number. Instead of memorizing this, it's better to understand the why of what we did with the last 4 slides. That way you're understanding why things are happening and not just memorizing different procedures, because all of a sudden procedures start looking the same. Let's try multiplying without calculators now. Multiplication can be done in a couple different ways. The first way is the way that a lot of students have learned how to do it. We have 532 times 67. To do this multiplication, we're going to multiply 7 times 532 and then 60 times 532. So first we'll multiply the 7 times 532. 2 times 7 is 14, so we have a 4, and we carry the 1. 3 times 7 is 21, and we have to add that 1, so that's 22, and we carry the 2. 5 times 7 is 35, add 2 is 37. Now we're doing 60, the 6, times 532, so we need a 0 here as a placeholder, and then we can do the same thing we just did. 6 times 2 is 12, carry the 1. 6 times 3 is 18, plus 1 is 19, carry the next one. 5 times 6 is 30, plus 1 is 31. And then we add these two numbers together. We have 4, 2 plus 2 is 4, 7 plus 9 is 16, carry that one. 1 plus 3 plus 1 is 5, and 3. So our final answer is 35,644. Many of my students have trouble with this algorithm. So another way to multiply, and this will work when we start doing multiplication with polynomials also. So the way to multiply, we have 532, so that's why there's 3 boxes here, 532, and 67, that's why there's 2 rows. So 532, there's 3 columns, 67, there's 2 rows. You could set it up the opposite way if you wish. Now we're going to draw diagonals in all of our rectangles. This is going to show us where we need to add when we're done with our multiplication. And now we're just going to multiply. This box is the intersection of the 5 column and the 6 row. So we're going to multiply 5 times 6, which is 30. This box is the intersection of the 5 column and the 7 row. So that's 5 times 7, which is 35. Here we're going to put an 18 because that's 3 times 6. Here's 3 times 7, which is 21. 2 times 6 is 12. And 2 times 7 is 14. Now we can add along these diagonals. We're going to start here. 4. 2 plus 1 plus 1 is 4. 1 plus 8 plus 2 plus 5. I'm going to start with the 8 plus 2 because that makes a 10. 15, 16. And we have to carry our 1. 3 plus 1 plus 1 is 5. And 3. 3, 5, 6, 4, 4. 3, 5, 6, 4, 4. Our final answer then is 35,644. Now we want to multiply negative 5b times 4 plus 3b. So we have negative 5b times 4 plus 3b. We're going to use our distributive property of multiplication over addition and multiply. So we're going to multiply the first two terms together first, and then the last term. So we have negative 5b times a positive 4. We just found out that a negative times a positive is negative. So negative 20b, and negative 5b times positive 3b is minus 15. B times b is b squared. To do this using the box method, we have 4 plus 3b and a negative 5b over here. Same thing, we're going to do 4 times negative 5b is negative 20b. 3b times negative 5b is negative 15b. And then we have negative 20b minus 15b squared. Oops, I forgot the squared. Now we want to multiply x plus 1 times x minus 3. There's no symbol here, so it's multiplication. Now remember, when you're doing problems, look and see if there's an addition sign in between, then you just add. If there's no addition sign between the parentheses, then it's multiplication. So we're going to multiply x plus 2 times x minus 3. This is x plus 2 times x plus x plus 2 times a negative 3, using our distributive property of multiplication over addition. Now we can distribute again, and we have x squared plus 2x minus 3x, because I did negative 3 times x, and 2 times negative 3 is negative 6. Now we combine like terms. We have x squared minus x plus 6. Get our equal signs in there because they're all equal. Many people skip this step here and just start here. So it was this, x times x was x squared. X times negative 3 is negative 3x. 2 times x is 2x. And 2 times negative 3 is negative 6. Doing it as the box method, we have x plus 2 and x minus 3. This is x and x, so this is x squared, and 2x, 2 times x is 2x, x times negative 3 is negative 3x, and 2 times negative 3 is negative 6. Just like in our previous example when we were doing it without just numbers, we added along the diagonals. So here we have negative 6, here we have 2x minus x is minus x, and here we have x squared. And we end up with the same answer both ways. So another example, we have 4x plus 3 times 7x minus 2. We're going to do 4x times 7x is 28x squared. 4x times negative 2 is negative 8x. 3 times 7x is plus 21x. And 3 times negative 2 is minus 6. Combining like terms, we have 28x squared plus 13x minus 6. Doing it with the box method, we have 4x plus 3, 7x minus 2. 4x times 7x is 28x squared. 3x times 7x is 21x. 4x times negative 2 is negative 8x. And 3 times 2 is negative 6. 3 times negative 2 is negative 6. And now add along our diagonals. And we have 28x squared plus 13x from 8x, negative 8x and 21, and minus 6. Another example, we have A and B, 3A and negative 4B. A times 3A is 3A squared. B times 3A is 3AB. A times negative 4AB, negative 4B is negative 4AB. And B times negative 4B is negative 4B squared. Adding along the diagonal, we end up with 3A squared minus AB minus 4B squared. And if you noticed before, this, the inside here, is what ends up happening when we do the distributive property of multiplication over addition also. So we have A times 3A is 3A squared. A times minus 4B is minus 4AB. B times 3A is plus 3AB. And B times minus 4B is minus 4B squared. So this is the inside of this box here. Then again, we combine like terms and have 3A squared minus AB minus 4B squared. Here's a bit longer one. This box method does help when we have something more than a 2 by 2 because then we don't forget any terms. So on the 3 columns, we're going to put the expression with 3 terms. So a squared minus 2ab and b squared. And with the 2 rows, we're going to do a plus b. Now we have a squared times a is a cubed. Negative 2ab times a is minus 2a squared b. B squared times a is a b squared. A squared times b is a squared b. Minus 2ab times b is minus 2ab squared. And then b squared times b is b cubed. Adding up all the diagonals, notice the a squared b is in this diagonal and ab squared is in this diagonal. We have a cubed minus a squared b minus 2a squared b is minus a squared b. And now we have minus ab squared plus ab squared, so that's minus ab squared, and then plus b cubed. If we do it the other way, using the multiplication property of addition over, or the distributive property of multiplication over addition, we have a plus b times a squared minus 2ab plus b squared. It's best to multiply the a times all of this first. So we're going to do a times a squared is a cubed 8 times minus 2ab is minus 2a squared b. A times b squared is plus ab squared. Now, instead of having a big long line of things over here and being consistent with what we were doing in the addition section, we're going to take b times everything, only we're going to line up our like terms. So b times a squared is a squared b, which is like terms with this one. B times minus 2ab is minus 2ab squared, and then b times b squared is plus b cubed. Now we can add vertically like we're used to, and we have a cubed minus, because we have minus 2ab a squared b plus a squared b is minus a squared b minus ab squared minus 2ab squared is minus a b squared plus b cubed. The same thing happens when we multiply complex numbers. We have 11 minus 4i and 2 plus 3i. So we have 11 times 2 is 22. Negative 4i plus 2, or times 2 is negative 8i. 11 times 3i is 33i, and negative 4i plus 3i is negative 12i squared. Remember, I squared was negative 1, so negative 1 times negative 12 is actually plus 12. We'll put that in a different color though, so that we remember it's a little bit, there was a step that we took that way. And so now we have 22 plus 12 is 34, and then 33i minus 8i would be plus 25i. Again, if you did it using the distributive property, this would be all the terms that you would have, and you would simplify by combining like terms again. Multiplying scientific notation problems. Remember, multiplication has the commutative property. So this is 4.3 times 10 to the 8th times 3 times 10 to the 7th. We can multiply in any order. So we can do 4.3 times 3 together, and we can do 10 to the 8th times 10 to the 7th together. 4.3 times 3 we'll do over here. That's 9 and 12. So, and then with a decimal point, there's one decimal point, so we're going to have one decimal point here. If we wanted to write this, because it says our final answer should be in scientific notation, if we want to write 12.9 in scientific notation, that's 1.29 times 10 to the first. So now we did 4.3 times 3, so, and we found out that was 1.29 times 10 to the first, and we're multiplying that times 10 to the 8th times 10 to the 7th. Anything with the same base, so all of these have 10s, and multiplication, we can add our exponents. So our final answer is going to be 1.29 times 10. We have 1 plus 8 plus 7 is 16. Again, for this one we have 4.3 times 3. because we can multiply in any order. And then we have 10 to the 8th times 10. Oops, let me erase that. Times 10 to the negative 15th. Again, our 4.3 times 3, we found out right here, was 1.29 times 10 to the 1st. And then we're multiplying by 10 to the 8th and 10 to the minus 15th. So our final answer is 1.29 times 10, and we're going to add our exponents because there's the same base. So we have 1 plus 8 is 9, minus 15 is 10 to the negative 6th. And that is scientific notation. Our last one, we're going to do 5.1 times 2, so that would be 10.2, which is equal to 1.02 times 10 to the 1st. And then we're going to do 10 to the negative 7th times 10 to the negative 14th. So that's 10 to the negative 21st, because we have the same base, we're adding our exponents. So our final answer is 1.02 times 10 to the 1st times 10 to the negative 21st. So now we still have to add a couple exponents. So that's 1.02 times 10 to the negative 20th. That's it for today. See